It's hard to imagine our planet without its iconic ice caps, but the Earth has been mostly ice-free for a lot of its history. And although glaciers are common sights in places like Antarctica, the Arctic and Greenland today, they also once covered huge parts of North America, Europe, and Asia. Welcome to my channel, and today let's find out what Earth was like the last time it was completely free of ice. The Quaternary Ice Age started around 2.6 million years ago, and we're still in it. In fact, according to experts, as long as Earth has large ice sheets in both the northern and southern hemispheres, we will still be considered to be in an ice age. So, we're still in the middle of one. But how long did the last warm period, which preceded the Quaternary Ice Age, last? When the last interglacial period ended, a new ice age began, and our ancestors were already prepared for it. As of today, the warmest regions on Earth are located in the southern part of South America, southwestern Africa, and Southeast Asia. Conversely, the coldest areas are in the interior of continents and high altitudes. So it's easy to imagine that during the last interglacial period, when the climate was warmer, these areas were covered in thick vegetation, while the rest of the planet had a tundra-like climate. This was probably the reason why the remains of animals similar to today's giraffes, elephants, rhinoceroses, and antelopes have been found in North Africa, indicating that large mammals could roam freely across the continent. Moreover, the fact that the mammoth steppe ecosystem existed in Europe points toward the presence of dense grasslands in that area as well. This is because the mammoth preferred steppes over forests, meaning that there must have been open fields for them to thrive. So the warm period before the current ice age lasted several thousand years. But it was not the last time Earth was totally devoid of ice. Going back millions of years, we can see that from 56 to 34 million years ago, the planet experienced a climate relatively similar to what we have today. During this time, there were periods with no glaciers, no ice sheets, and no permafrost, meaning Earth was entirely free of ice. However, unlike today, back then the continent of Antarctica was located much closer to the equator, resulting in significantly higher temperatures. So while we may think that the climate was just like today's, it was actually much hotter. But what do the scientific data say? Well, researchers have been able to reconstruct what the climate was like back then by analyzing oxygen isotope ratios in fossil shells and teeth of marine organisms collected in Seymour Island in Antarctica. From this study, scientists determined that during the Eocene, average temperatures in Antarctica ranged from 10 to 15 degrees Celsius, with summer highs reaching 25 degrees Celsius. For comparison, in the 20th century, the average temperature in Antarctica was around minus 56 degrees Celsius. Therefore, we can conclude that this was a greenhouse world. The main greenhouse gases were water vapor and carbon dioxide. In fact, carbon dioxide levels could have reached 600 parts per million, which is twice as much as they are today. Due to these conditions, Antarctica was covered in rainforests, with more than 2 meters of rainfall per year. Also, since the polar regions receive very little direct sunlight compared to equatorial regions, it is unlikely that the surface of the Earth there could have been as hot as in the tropics. Probably the only place on Earth where the temperature really got high was in the ocean, especially at depth. Researchers believe that due to the absence of deep ocean currents, the water in the ocean depths did not mix with the cold water coming from the poles. This led to the formation of stagnant waters that heated up and created the perfect condition for life to develop. This is evidenced by the fact that during the Eocene, the oceans teemed with gigantic creatures such as megalodons, armored crustaceans called carcinoids, and, of course, Basilosaurus were a group of primitive whales that lived between 50 and 35 million years ago and were the apex predators of the oceans. Some species could grow up to 15 meters long and weigh about 36 tons. They were perfectly adapted to hunt in the ocean depths, and possessed some characteristics of modern whales, such as horizontal tail, flukes, dorsal fins, and streamlined bodies. Fossils of these giant beasts have been found on every continent, which shows that they were distributed worldwide. Imagine what it would feel like to be swimming in the ocean and come face to face with a gigantic toothed whale ready to devour you. Indeed, these creatures were not afraid to attack even other whales. So what does science say about what the rest of the world was like? First, we need to talk about Antarctica. Back then, the continent was connected to South America, forming a land bridge. This allowed mammals from South America to migrate to Antarctica and vice versa. Because of this, Antarctica had a wide variety of native mammals, including whales, dolphins, bats, rodents, carnivores, herbivores, primates, hoofed animals, marsupials, and even proboscis. Scientists estimate that there were around 300 species of land mammals in Antarctica. Other Antarctic animals included lizards, snakes, turtles, crocodiles, frogs, fish, birds, beetles, spiders, mollusks, corals, and more. This rich biodiversity was possible due to the warm climate that prevailed in Antarctica at that time. Now let's move on to the rest of the world. During the Eocene, most of the major continental landmasses were joined together in a supercontinent called Gondwana. Gondwana was surrounded by a vast ocean called the Southern Ocean, which separated it from other landmasses such as Asia, Africa, and Europe. The climate in these regions was generally warm and humid, although there were significant variations depending on the proximity to the equator. Near the equator, the climate was tropical and rainforest dominated. As we move away from the equator, the climate became drier and more temperate, giving way to grasslands and deciduous forests. Towards the poles, the climate was cooler and wetter, leading to the formation of coniferous forests, and eventually the highest temperatures were recorded in the western tropical regions of Gondwana, such as in what is now Brazil, where temperatures reached around 35 degrees Celsius. On the eastern coast of Gondwana, including areas that are now New Zealand and Australia, a Mediterranean type of climate prevailed with hot, dry summers and cool, damp winters. Western Gondwana experienced frequent rainfall, while eastern Gondwana was drier. The interior of the supercontinent was mostly arid with desert-like conditions. During this era, Gondwana was home to a diverse range of plant and animal species. In the tropical regions, we find ancient tree species such as Araucaria, Glossopteris, and Podocarps. The diversity of flora and fauna was enormous, including early primates, ancestors of modern bats, various reptiles and amphibians. Large flightless birds also inhabited the isolated forests of New Zealand and New Guinea. While Gondwana enjoyed relative warmth, the Northern Hemisphere was experiencing significant climatic changes. After breaking away from the supercontinent Laurasia, North America began to drift towards the North Pole. This caused drastic changes in its climate as it moved from a temperate to an Arctic climate. As North America approached the pole, the amount of solar radiation it received decreased dramatically, leading to a significant drop in temperature. This change in climate had a profound impact on the flora and fauna of the region. Many plant and animal species that had thrived in the previous warm climate became extinct, while new species adapted to the colder conditions evolved. In conclusion, the transition of North America from a warm climate to an Arctic environment during the Eocene marked a turning point in Earth's history. As the continent approached the pole, the decrease in solar radiation caused a dramatic drop in temperature, leading to the extinction of many species and the emergence of new ones adapted to the cold. This climatic shift had a profound impact on the evolution of life on the planet, and paved the way for the emergence of the iconic landscapes and wildlife of the Arctic region we know today. So while the Eocene was a time of great diversity and warmth, it also witnessed significant changes that shaped the planet's future. And that's all for today. If you liked the video, please give it a thumbs up, and don't forget to subscribe for more amazing content. Thank you for watching, and I'll see you next time. So, what was life like on Earth during the age of mammals? You've got your giant saber-toothed cats, your terror birds, and your rhinoceros-like creatures named Well, it turns out that there is so much more to discover about the Eocene. Join us as we look at some terrifying new discoveries, including the first glimpse of an ancient whale carcass, the proof of a horrifying predator, and the unveiling of a lost mammal from Wyoming. Lost whale carcass, one of the greatest mysteries of any extinct animal, is what happened to its body after death. How did it decay? Was it picked clean by How long did it take for its remains to be lost to time? Well, recently, scientists uncovered the very first fossilized whale carcass from the Eocene. The specimen is from a period when whales were transitioning from land to water, so studying it will help researchers learn more about how ancient whales lived. To date, they've uncovered the skull, vertebrae, ribs, jawbones, and other fragments, and it has all been preserved in such good condition that scientists can make out the structure of the ribs and see details on the bones like muscle attachments. It's even believed that some soft tissue may remain, which could preserve evidence of collagen fibers. What's more, the discovery suggests that whales may have washed ashore frequently even 50 million years ago, just as they do today. Perhaps they were coming closer to truly being ocean dwellers by the late Eocene, early relative of Megalodon. When we think of the largest sharks that ever existed, we usually think of the Megalodon. This prehistoric shark could grow to lengths of 15 meters and was around for a staggering 80 million years. But you might be surprised to know that it wasn't actually the first giant shark. That title goes to the Otodus obliquus, which swam in the Eocene. The great shark lived across the globe, from New Zealand to the Pacific coast of South America, and it was active for a whopping 10 million years. All that time it was hunting in the same oceans as the Basilosaurus. For a long time, it was thought that this predator died out before the basilisk arrived, but new research suggests that the two giants overlapped for hundreds of thousands of years. If you thought the basilisk was scary, then prepare yourself, because the obliquus could reach lengths of 12 meters. It's considered to be one of the largest cartilaginous fish that ever existed. It had to be incredibly powerful to move its huge frame through the water and hunt down prey. And it had an incredible bite force. In fact, it had the strongest bite of any shark that ever lived, even stronger than the T-Rex. Its jaws could exert a jaw-dropping 30,000 pounds per square inch of pressure. Now, unlike the Megalodon, the obliquus had a relatively short lifespan, only living for 50 to 60 years. That might not sound too long when you and I are over 100 years old, but considering that it reached sexual maturity at 12 years old, this meant that it didn't get much longer to dominate the oceans before dying off. Terror birds during the Eocene, birds were everywhere, and the most diverse and dominant group was the retidae. Today, this group consists of flightless birds like emus, ostriches, and kiwis. But in the past, they came in all shapes and sizes, and some were far more fearsome than their modern relatives. Terror birds were the apex predators of the Eocene, possessing the most powerful grip of any bird in history. Their legs were like iron, and they had giant hooked beaks perfect for tearing apart flesh. In fact, their skull and beak structure resembles that of a hyena, allowing them to easily crush bone. Scientists believe that teratorns fed mainly on carcasses, often fighting each other to get the best pickings, but given their strength, they could have taken down live animals, too. And though they are long extinct, they may have left behind some mysterious descendants. Some scientists believe that terror birds were once white-throated or Andean condors. Their ancestors simply evolved into larger forms that lived on the ground. Biggest snake ever in today's world. Snakes come in all different shapes, sizes, and colors, from brightly colored coral snakes to gigantic pythons. These legless lizards are perfectly suited to their environment. But as fascinating as they are, we couldn't imagine running into one in the wild. However, during the Eocene, things were much different. Back then, the world was home to the largest snakes that ever slithered the earth. These were the paleophids, a group of marine reptiles that lived in the world's oceans. Paleophids were basically giant eels, and they could grow to lengths of 12 meters or more. They had cylindrical bodies, pointed snouts, and tiny heads. This body shape would have allowed them to swim effortlessly through the water and ambush their unsuspecting prey. Like modern snakes, they constricted their prey before swallowing it whole. But these guys were eating sharks, and even whales. And perhaps the strangest thing about paleophytids is that they weren't just limited to the oceans. Their fossils have been found in freshwater deposits, meaning that they could survive in both salty and fresh water. Some paleontologists believe that they were even amphibious and could venture onto land. So, if you're ever strolling along the beach and spot a large eel slithering up the sand, you'll know exactly what to blame. Whale ancestors back in the day, whales were very different from how we know them today. They were smaller, had shorter snouts, and were more agile. They needed to be because they were still getting the hang of living in the water. Whales evolved from land-dwelling mammals, and their early ancestors looked more like hippos. Over millions of years, they changed. Their neck became lighter, their tail grew longer, and eventually they were fully adapted to life underwater. But the transition didn't happen overnight, and the change was gradual. In fact, evolution was still happening during the Eocene, and this is why researchers are excited about the recent fossil discoveries. The remains of a mysterious whale were found in Peru, and it's helping scientists close a major gap in their understanding of whale evolution. It's believed to be one of the oldest humpback whales ever found, and it was born about 36 million years ago. This was during the Eocene epoch, and the whale was just 7 meters long. Today, humpbacks can reach 16 meters in length, so it's clear that whales continued to grow throughout history. Giant primates. During the Eocene, the world looked vastly different than it does today. The continents were in slightly different positions. The climate was hotter, and almost every habitat was filled with giant animals. And primates were no exception. Back then, the world was home to giant lemurs that looked more like furry gorillas. But arguably the strangest primate of the Eocene was the Megalodon grossophus. This mammal was literally a monkey with tusks. It belonged to a group called the Sarcopithecidae, but somehow it developed fangs. Its ancestors were probably ordinary baboons that mutated, giving rise to this bizarre creature. Most of what we know about Megalodons comes from a single fossil found in Wyoming. It's been nicknamed the unicorn monkey, and it was likely around 4 feet tall when it roamed North America. The land before time, as mentioned before, the Eocene was a time when life returned to the land. After the mass extinction of the Cretaceous, most habitats were empty, and this gave new species the opportunity to evolve and diversify. The warm climate led to the expansion of rainforests, which were teeming with giant mammals, birds, and reptiles. Plants grew abundantly, providing food for animals and a constant source of nutrition. And the Eocene was particularly special because it saw the rise of some of the most iconic mammals in history. The lemastilids were one such group. They were hoofed mammals that emerged during the Eocene, and their name means near horse. But despite their name, they aren't closely related to modern horses. Instead, they're more closely related to rhinos and tapirs. Lemastis were anywhere from 3 to 5 meters in length, and they walked on 3 toes, with the middle toe being the largest. Unfortunately, they disappeared at the end of the Eocene, possibly due to changing environments. But their legacy lives on in modern animals like the okapi, the only living relative of the ancient forest mammal. On your mark, get ready. Go back in time to the Eocene, and you wouldn't believe your eyes. You'd see giant kangaroos, monkey-like baboons, with tusks, and giant whale monsters. These animals and many more prove that the Eocene was a unique and extraordinary time in history. Target ended 34 million years ago. It continues to fascinate scientists and inspire wonder in all of us. Thanks for watching. Be sure to hit that like button for more videos. Hi everyone, I'm here. When you hear Ice Age, you probably think of saber-toothed cats, woolly mammoths, and humans making cave paintings while wearing loincloths. But the Ice Age actually began millions of years before any of those things evolved. In fact, it's still going on today. And while it may seem like humans are at the heart of the story, our own evolution wouldn't have been possible without it. It's me, and this is my channel. In the aftermath of the mass extinction that killed off most life on Earth, the Cretaceous, mammals were small, furry, and numerous. Yet for many of them, survival was not guaranteed. Predators came in all shapes and forms: reptiles, birds, and of course, other mammals. For example, there were the hyaenodonts, a group of mammal-like reptiles that appeared shortly after the mass extinction. These were truly terrifying creatures. Some grew over 3 meters long with massive skulls and bone. Crucind, hows. They hunted large plant-eating mammals, crushing their bones with ease. Then there were the bear dogs, a group of carnivorous mammals that got their name from their skull shape, which resembled modern bears. Their teeth were long and sharp, ideal for catching and tearing up prey. Finally, let's talk about the entelodonts, or hell pigs. Yes, that really was their name. These mammal-like creatures developed from ancestral pigs and grew into hulking, short-snouted monsters. Some weighed over 2,000 kilograms, and their tusks could grow nearly a meter long. But despite these imposing figures, mammals steadily pushed back against the reptilian onslaught. Some did so by being speedy, like the ancient ancestors of horses. Others fought fire with fire. Groups like the nimravids were ambush predators. They stalked their prey before delivering a devastating bite. They didn't look like cats, but they acted like them. They moved through the underbrush with a panther-like grace and used their massive fangs to deliver a killing bite. These canines were saber-like, curving into sickle shapes, perfect for slicing open chests and slashing through arteries. They weren't true cats, but they hunted much like them, and just like today's big cats, they left their mark on their victims, ripping out huge chunks of flesh with every swipe. The battle for dominance between mammals and reptiles was fierce, and for a time, Earth's throne seemed divided. But then, everything changed. Let's rewind the clock to 34 million years ago. At this point, mammals were widespread across the globe and many different types had evolved. There were plenty of furry proto-wombats, small bear-like creatures called perissodactyls, and even a few primitive primates. Meanwhile, reptiles included mosasaurs, giant marine lizards that ruled the oceans, and snakes that had grown long and lean, perfectly suited for life after the asteroid impact. But this prosperity would not last. Around 34 million years ago, the Eocene epoch gave way to the Oligocene. That's right, there are multiple ice ages. And at this point, you're probably thinking, wait, what happened to the dinosaurs? Well, the truth is, the ice started well before then. During the Cretaceous, parts of Antarctica and Greenland were covered in ice. However, this changed when the supercontinent Pangaea broke apart. Warm ocean currents flowed through the open water, keeping Antarctica warm. This allowed flowering plants to thrive, insects to flourish, and eventually mammals to diversify. But all that would soon change, because as Pangaea continued to drift, Antarctica began to separate from South America and Africa. As it drifted farther south, it became isolated, preventing warm currents from reaching the continent. This change allowed for the formation of the Antarctic Circumpolar Current, a ring of freezing water that cut Antarctica off from the warmer climates of the north. Suddenly, Antarctica was plunged into near-freezing temperatures. What happens next will sound familiar. Once ice began to form, it created a feedback loop. The ice reflected more sunlight, lowered temperatures further, and allowed glaciers to spread. Before long, the world was locked in an ice-making machine and Earth was headed toward another ice age. In order to understand how the ice age affected the development of life on Earth, let's take a closer look at what was happening around 34 million years ago. During the Eocene, most of the planet was covered in rainforest. It was hot and wet. The Amazon rainforest was huge, stretching from modern-day Brazil to southern Europe. And in North America, giant leafy trees reached 60 meters high. But as temperatures dropped, forests began to shrink. A new biome began to emerge, one we're all too familiar with today: grasslands. Grasses spread across Eurasia, Africa, and North America. By the end of the Oligocene, grasslands had become the dominant ecosystem, covering nearly half the planet. Meanwhile, the Eocene saw a huge explosion in diversity for mammals. Over 500 species lived during this time, including early ancestors of whales, rhinos, and elephants. As mammals diversified, they began hunting grasses, but the grasses fought back by evolving tough leaves and stems made of silica, a natural form of glass. To compensate, mammals evolved stronger teeth and jaws to help them slice through the fibrous plants. But this arms race came at a cost. These mammalian teeth required significantly more energy to grow. In response, mammals evolved larger bodies to meet their energy needs. This led to a bizarre situation. Just as mammals evolved to hunt tougher grasses, the grasses evolved to become even more difficult to eat. Mammals responded by getting even bigger. This trend toward gigantism continued until the middle of the Miocene, when something unexpected happened. A feedback loop began, shrinking the size of mammals across the board. Scientists aren't exactly sure why this occurred, but it likely had something to do with the changing climate. With resources becoming less abundant, smaller animals were able to find food and shelter more easily. This shift toward smaller bodies continues to this day. In general, today's mammals are significantly smaller than their Oligocene counterparts. But as mammals flourished, other groups struggled. Remember those ancient reptiles that dominated the late Cretaceous? Well, they didn't stand a chance in the face of this new mammalian competition. Mosasaurs went extinct at the end of the Cretaceous, thanks to the asteroid impact. And afterward, mammals seized the opportunity to diversify. As for snakes, their long, lean bodies helped them survive the initial asteroid impact. But the following ice age proved to be their downfall. Like today's snakes, Most ancient snakes were cold-blooded, relying on the sun to warm their body. But as temperatures dropped, snakes faced a problem. It took longer for them to warm up in the morning, meaning they spent less time searching for food. So to compensate, snakes evolved too fast for longer periods. But as the Ice Age dragged on, snakes pushed their fasting abilities to the limit. Eventually, some species couldn't go on without dying. They simply burned out. This was also a mass extinction event, but nowhere near as severe as the asteroid impact. Between the Eocene and Oligocene epochs, approximately 15% of marine species went extinct, along with 30% of terrestrial vertebrate species. For mammals, however, it was a time of prosperity. As reptiles declined, mammals began to fill their empty shoes. In fact, it's because of this event that modern ecosystems are dominated by mammals rather than reptiles. If the Ice Age hadn't rolled around when it did, mammals might never have had this opportunity. So how long will the current Ice Age last? According to some scientists, another 50 million years. But don't worry, we won't be around to see it. Now, check out what would happen if the Earth had no gravity. Or watch this video instead.